We're going to go ahead now and take a look at integer multiplication and division. And as we studied addition and subtraction, kind of with the different models, measurement models and set models, we carry that over to multiplication and division. As we remember, multiplication can be viewed as repeated addition, subtraction is division is a repeated subtraction, right? We know that there's these connections between addition, subtraction, multiplication, and division. And so that's how we start this section of multiplication of integers, positive and negative numbers, with repeated addition. 3 times 4 we know is 4 plus 4 plus 4. And then we also then look at 3 times negative 4 would be negative, 3 groups of negative 4. And so we can see that as repeated addition. We can also see it on this measurement model here, looking at this here, going back for 4 and 4, and now I'm 12 away in the left direction, right? So I'm in that space there. And so rules for integer multiplication can be motivated by patterns, right? Because we end up with this idea of a negative times a negative, right? And so looking at first the positive times the negative, look at the pattern, 3 times 4, 3 times 3, as it starts to go down, my product, right, the result I get when I multiply keeps going down by 3. So once we get 3 times 0, 0, what do we guess 3 times negative 1 is? Well, if we're just going by pattern, it's negative 3. So that's what generates our rule here, that a positive times a negative is a negative. That also matches up to our measurement models or repeated addition ideas. 3 times negative 2, 3 times negative 3, and so forth. Now let's play the game of a negative 3 times. So I start with that going first. And so negative 3 times 3, we can see we're going to learn multiplication is commutative. So we could flip it and still get that same answer here and here. But again, now that we have this idea, we could, negative 3 times 2 is negative 6, because we could flip-flop one group of negative 3, 2 of negative. We know that those are the answers, but we also see by the pattern, negative 3 times negative 3. So this is 0. And then notice it's going up by 3 every time. So negative 3 times negative 1, this is going up down by 1. This is up by 3. From a pattern, it seems to generate a reason why a negative times a negative would equal to a positive. And so looking at that, it's important to how that generates our idea of why a negative times a negative is a positive. One very distinct way of looking at that is through this pattern development. And then you could try with another number and see how that works out. We also played with integer tiles. Remember, we had the 2 counting chips that we looked at. And so looking at that, you do it by how many groups, right? And that's, again, kind of connected to repeated addition in terms of here are 4 groups of negative 3. Altogether, you have negative 12. If we were in class, we'd have a chance to discuss this, right? This idea of the meaning of each of these things, right? And so we would be discussing what meaning you had to assign to each of the symbols in order to model the products with the chips. And so trying to look at using like physical tools would be what we would get a chance to do here. But I want you thinking about that. Get your chips out or go to the website that we have and kind of play with that. What does this look like? 3 groups of negative 2, negative 3 times 2, this idea that you're taking away 3 groups of a positive 2. And here, taking away 3 groups of a negative 2, trying to model what that would look like, important task or something to try out.